If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture intermediate level where we are seeing coordinate geometry circles for JEE Main and Advance. So today we will see the condition for tangency of a circle. That means what condition a straight line will be a tangent to a given circle. Okay, then let's see this. Now next to find this article is condition of tangency with respect to a circle. Now how to find whether a straight line given will be a tangent to a circle or not, or what should be the condition so that it become tangent. So what is given to you, a circle is given to you, a straight line is given to you. So now you have to check whether it is touching the circle or not, or you have to find a condition from this so that if that satisfied, then it will always touch it, or it will be always tangent. So for the line it has to be tangent because it has to touch it. So this length CP should be equal to radius. If this is from the point, if you take a perpendicular distance, that is CP, that should be equal to radius if it is a tangent. So how to find a perpendicular distance from a point to a line, we have already explained. This one I have taken a circle which is a standard form because I have not taken general form, otherwise the formula becomes very big. So in this case every time it is standard format is given, so the formula becomes simplified. But you have to remember the formula also, then and you have to remember the concept also, from where it is coming. The idea is simple. You take the distance from the zero, from the origin to the line. If that is equal to radius, then it is touching. So if it is not in standard form, if it is in general format, so this formula you cannot use there. So there you have to use this, from where it is coming, the concept you have to use, and you have to derive something. You have to find the answer. Directly you cannot apply the formula. So the idea is same. From this point you find the distance. So how to find from a point to a line the distance, this distance? You can remember ax1 plus by1 plus c divided by under root a square plus b square. This was the formula for the distance from straight line. So you put it there. So if you put the point here, so it is y minus mx minus c equal to 0. So your point is here 0 0. So it is 0 0, then minus c. It is mod there, so I removed that mod, put it there, plus minus. Divide by under root x square coefficient and y's coefficient. X is minus m, y is 1. So minus m is m square. So it is plus minus a because it was mod. I removed that mod. So if you take square, it should be, this is the condition. If this condition are satisfied, if c square equal to this, then this straight line will obviously touch it and will be tangent of this one. So this is the condition we have to satisfy. Now some conclusion we can draw from here, because see the value of c. It can be plus minus because c square is this much, so c can be plus or minus. That means if a slope is given to you, if m is given to you, then you can have two straight lines with two intercept. Because slope is given, both the lines will be parallel. Suppose this slope I have given you 1. So for 1, if you put 1, this circle is already given to you. If I give you a straight line with 1, then you will find two intersect, one with plus, one with minus, and both are parallel lines. So for same slope you will find, because you see the slope of this line is also m, this line is also m. So with same slope, for a given m, we will have two straight lines which are parallel, which will touch the circle. One is this, one is this, which will touch the circle, which will be tangent. So always you will have one pair of parallel lines which are tangent to a circle. Means if you find a straight line of m slope which is touching it, so you will find obviously another straight line of same slope which is touching it, and both will touch each other at just diametrically opposite, at the extremities of the diameter. This is one extreme of this diameter, this is one extreme of this. So the distance between them will be nothing but the diameter of the circle. So if you have a circle, if you have a tangent at this point, so obviously you will have another tangent which is parallel to this line. You can see from the geometry itself, which is, and this distance will be the diameter. This line, this will be 90, everything will be 90 because my circle is not in shape because it is tangent, so it should be 90, the point at which it touch. So this perpendicular distance is also the diameter. So this conclusion we can draw. If you like the video, then press the like button and please give your valuable comments in the comment section.